Good morning, everybody. My name is Ashley Barger. Thank you so much for joining us today for another energy savings webinar from our series with Centurion Technologies. We are so pleased to have you today. We're going to keep this as quick as we possibly can. I do want to go over just some brief housekeeping. We will send out materials to all registered attendees after the meeting. The video and things will be live on our website under the new section. So you can go to centurionstechnologies.com and you can find all of these resources under the new section. Additionally, if you have questions during this webinar today, please use the chat feature. I will interrupt our presenter if I need to make sure questions are answered in a timely fashion. We can also hold those questions till the end. So please leave another couple minutes at the end of this webinar for us to answer those questions. So I did want to tell you just a little bit about Centurion Technologies today, because I did notice there were lots of attendees who maybe we've never met before. So I wanted to give you just a brief synopsis on who Centurion Technologies is and how we help across the nation and even internationally. So we do have partners in the energy sector. And with those partnerships, we're able to deliver sustainable solutions across the United States. So I won't read the slide for you, but there's some key core competencies here that I think that really hit home on what we're going to need to do in order to ensure all of our futures. So without further ado, I did want to introduce to you today Craig Kuchbal. He's the owner of Centurion Technologies. I just do the marketing. So I wanted to have Craig say a couple words. Hi, Craig.
Hi, Ashley, and thank you very much. Great introduction. I'd like to welcome everybody to our third in the series of our fall and winter webinars. Today, we are fortunate enough to have Schneider Electric with their Microgrid Competency Group on board. So without further ado, I want to turn it over to Lamisa, and we can get started on it. Thank you for joining.
Thanks, Ashley, and thanks, Craig, for putting this together. And thanks to Centurion Technologies for kind of giving us this platform to talk about future-proofing your energy infrastructure with microgrids. Before I get started, I'll do a quick introduction of myself. My name is Lamisa Sheikh. I've been with Schneider for about 2 years now, and I'm an engineer on our microgrid partner team. So I support our partner-led initiatives, projects, and strategy, which is really important, as you'll hear, when it comes to the launch of our new product suite, Microgrid Flex. But before I get into that, I'll kind of run through some market trends that we're seeing, some challenges in the energy industry, and then we can go into the high-level overview of what is a microgrid. And then finally, we can kind of dive into that product suite that I was talking about, Microgrid Flex. And if we have some time, we can talk about a few completed projects and some of the outcomes of those projects and lessons learned. And I'll also have a colleague on, and hopefully she'll be able to join and talk about incentives and funding. So we'll save that for the end. And if you have questions, as Ashley had said, feel free to enter them in the chat. I have a few colleagues on with me as well, so they'll be able to monitor that, and we can get those answers to you. Awesome. All right. So before we dive into the technology, let's cover why this market is important and some trends that are reshaping our energy infrastructure. So we know that climate change remains one of the most pressing challenges of our time, and we know that decarbonization is the best way to slow it. We also know that electricity is the most efficient energy form and the best vector for decarbonization. And that being said, we also are seeing our electricity usage trend upwards. So if you think about it, how we live and how we work, we're able to do this webinar remotely. If you think about how we live specifically, building electrification, the digital solutions in our daily lives, and how we're getting from A to B too in a more sustainable way with the shift to electric vehicles. We need to be able to meet these demands, and a large part in doing so is going to be to rely on renewable energy. And with the rise of electricity demand, the cost is also spiking. So we're seeing not only volatility in cost, but also in reliability. Outages continue to be a big problem, especially when you begin to think about climate disasters and critical facilities like hospitals. And the best way that we're going to be able to tackle this is through a decentralized energy system that is going to provide behind the meter flexibility and reliability as well. And this kind of brings us to the new energy landscape. And it's kind of a result for some of those obstacles that we're facing. So this new energy landscape is what we call it. It's going to transform that one directional centralized model to this new value chain where the energy consumers are going to become prosumers. They're going to be producing their own energy and also choosing when to use it, store it even, or sell it back to the grid. And microgrids are key to this. They're going to enable our customers to become prosumers, and they're critical to the new energy landscape. All right. So now that we know that it's really important, what is a microgrid? So it is an integrated energy and power management system with interconnected loads and distributed energy resources that are operating in parallel with the grid or in an islanded, isolated mode. So what are these distributed energy resources? It can be things like solar, battery, wind, just different types of generated resources that make a single entity. And our goal as a microgrid technology provider is to make the most out of that system and solve a few issues while we do that. So that's going to include energy costs. As we were saying, our customers have seen a rise in energy costs over the last few years, and that's only going to continue. So one way to solve this is just to own and operate your own energy system. Sustainability is another big piece of it. A lot of companies and customers are setting sustainability goals and trying to reduce their carbon footprint. So to meet these goals, this comes into play. And then there's also resiliency. We know that some critical buildings, they're already built with a backup diesel generator, but a lot of people are saying sustainability is also really important with that resiliency aspect. So how can we use that generator and other more sustainable resources to solve some of those challenges in one single entity, in that one cohesive package? All right, so there are three types kind of microgrids, and I'll briefly go through this. So one, grid tied, when it's always connected to the main grid, or it can be an islandable microgrid, which is similar to that grid tied microgrid, but it can actually disconnect itself from the grid in case there's an outage or a failure. So it has the capability to operate in this islanded, isolated mode, either powering the whole site or the most critical parts of the system. And that's really increasing the site's resiliency. And then we have the off-grid microgrid, which is never connected to the main grid. And the goals are similar. It's to guarantee that power supply and reduce the energy costs and carbon footprint. But off-grid microgrids, they don't require certain use cases like utility tariff optimization or demand response because they're not really participating to the main grid. All right. So now that we kind of know what they are, how do they work? What happens in a microgrid? Most of the time, it's kind of in the normal mode. It's consuming energy and lowering the energy bill for the customer, or even selling it back to the grid, depending on how it's set up. And what's key is like what happens during the outage. So whether that's a planned outage or a power outage or failure, how can the microgrid be used for the resiliency application? So your normal mode, and then the grid goes out. The battery or generator will start as a grid forming asset. The microgrid will stabilize and then bring on the distributed energy resources in a grid following mode. So running that generator at its highest efficiency while also using the maximum amount of renewable energy so that you're using the least amount of diesel fuel. So it's trying to be as efficient with those resources as possible. And then once the microgrid kind of recognizes that the grid is stable, we can go back to that grid stable power, stop the microgrid, reconnect to the utility, and return back to that normal mode, that economic optimization mode. So why are people interested in microgrids? Why is this kind of a buzzword nowadays? And why are we seeing more of this technology? We can kind of categorize this into four major drivers, and we already touched on a few of them: the resiliency aspect, cost optimization, and the sustainability piece. And we know that our grid, it's facing a lot of challenges, as we kind of covered, more frequent, longer outages due to storms, wildfires, capacity, or even power quality issues. But there's another aspect that's kind of coming into this with buildings and expansion being a major driver. So if you consider EV charging, electric fleets, other electric loads that buildings are adding and might not be able to be served by the utility immediately, microgrids can actually supplement those time delays in getting a new utility connection by adding on-site energy resources and helping you add those loads. So you can expand your facility and move your business in the right direction. And it also adds that future-proofing aspect as well that we'll kind of dive a little deeper into. And who needs a microgrid? What are the segments that we're kind of seeing that are interested? And we don't really consider microgrids like segment specific, but an application that can serve many end users. So common examples: hotels, campuses, supermarkets as well, which is that's an interesting example, because if you think about how much power they're using throughout the day, if there is an outage, how much loss that would be with goods and refrigeration. Those critical facilities too, like hospitals and medical clinics. And another thing that we've kind of seen popping up is gearing up for EV charging. So adding EV charging to a site and kind of future-proofing in that aspect as well. I've seen a lot of projects come on in that aspect as well, because once you're adding those EV loads, that's another electric load that you're adding to your site. And the last kind of market piece that I'll kind of end with, and this challenge that I want to dive into a little bit before we get into the technology and the product suite, is this increased electricity demand that needs to be met. And this is coming from various different factors that we talked about: the electrification of buildings, but also from the AI boom in data centers, the electrification of transit. And then also there's this piece where we're seeing power plants are meeting the end of their lifetime as well. So it's kind of creating this gap, and it's another push towards driving more decentralized energy systems. All right, so we've spent the last few years developing some tools and go-to-market strategies to expedite our process as we deploy these microgrids. But before I kind of dive into what those tools are, I think it would help going over what the deployment process kind of looks like end to end. And this starts by understanding what the customer needs are and understanding their goals. Once you do that, you're able to do an assessment and see what's possible at their site. Once that's complete, you can do a feasibility study, and that's going to help you predict the financial cash flows, the KPIs, what are the savings, the return on investment as well. And once that is kind of complete, along with the design, you're able to build, install, and commission the site. And another key piece here is also to optimize and maintain. These projects are projected to last at least 25 years. So it's really key to be able to maintain them and also optimize them, so you're getting the most out of that one site and that one microgrid. Cool. And to get a little into those specific tools, we created this offer, Microgrid Flex, that I mentioned at the start of the call. And we created this offer to shrink that development process, move some of the complexities of our on-site work into our manufacturing sites and into our R&D lab, so that we can test, configure, validate, document all of these projects before it ever gets onto the customer site. So I can start by kind of going through these tools. The first one would be microgrid assessment. So this allows us to perform the feasibility part of that process diagram, and meaning that we get to choose the optimal DER sizing, we get some insight into financial decisions, and the tool actually will run through a real sequence of operations and real algorithms and provide a projection based on all of that. We also have EcoStruxure Microgrid Build, and this is a really innovative tool that brings down the soft cost by reducing our engineering time down by 80 to 90%. And this tool, it provides automatic code generation and pre-engineered microgrid controls around those standardized use cases, those pre-tested sequence of operations, including our library of supported distributed energy resources. So to kind of sum that up, the output of the tool is going to be these packages of code that go onto our devices that are the brains of the microgrid. And we've standardized and tested all of our code so that we can trust when that microgrid gets dropped off in the field, it's going to operate as we want it to. And then we have our hardware stack as well. So that includes the Energy Control Center, which serves as the brains of the system. It has a 3000 amp switchboard, all the microgrid controls, and we also have a battery storage offer as well. And tied to all of those hardware products are our operating software layers. They have been integrated, so there's real-time cloud data coming in that's helping us achieve those cost savings and making those energy saving decisions. And here, this slide kind of also highlights that partnership model. And that's kind of what my team works on, and why I was highlighting it's pretty important. This model helps us work with our partners to reach our end users, deliver this message and in our sales pitch, and drive business for microgrids. But it's also really key in having partners that are able to deliver, commission, and operate these sites as well. So I have a couple cool graphics. I wanted to tie this all back to how is Microgrid Flex important in terms of future proofing. So I have a few graphics that we'll kind of run through real quick, and I'll describe them as we go. But in this one, you can see, start from the beginning, this site is powered by the utility, it experiences an outage, and a generator is able to support those critical loads. Here you can kind of see what would happen if you added a microgrid to that. That microgrid is able to be powered on and support those loads with those distributed energy resources. And here you can kind of see what the ideal scenario would look like. And this is what kind of a future-proof site would look like. You're able to kind of harness the different energy resources, including renewable power, and use them in the most efficient, cost-optimized way to support your site. So 90% of the time, the grid is available and it's stable, but for buildings that have solar energy, they might be reducing their carbon footprint during that grid-connected operation. But we can go in and talk a little bit about the caveat to that and why like just solar wouldn't be sufficient, and why having this integrated microgrid would support those needs better. So for example, if the grid goes down and a site has solar, and that solar might not be able to support the facility. And we've seen this happen a lot in California. So these site owners are saying, that have adopted solar are saying asking why they would lose power during outage. And then they realize that the solar shuts off. And this basically happens because it's a safety measure. to ensure the solar isn't pushing power back while someone is out in the field working. But if it's designed in the right way, the solar can be available during an outage. And that's kind of what you're seeing here. And this is one step to future-proofing the buildings, making sure that the solar is designed in a way that it can be leveraged to support the site even during an outage. So we can talk a little bit about the next step when it comes to future-proofing. In a lot of areas, we're seeing a shift in electricity costs, and the cost of energy is changing throughout the day, and that's called time of use. And it's also impacting the financial equation for solar energy savings. So we're seeing an incentive to shift that solar energy that a building is producing to be used later in the day. And the best way to be able to capitalize on that is to store that solar. And not all areas have done that yet. Not all utilities have implemented this. But a microgrid would help you future-proof your infrastructure for that upcoming scenario, so that your building is prepared. And even if you don't have the battery storage system yet, you're set up to add that asset to your building in the future. And this future-proofing element that a microgrid can offer, and the forethought that will give your business an advantage as electricity costs and power outages continue to rise. All right. So we have some time, so I'll talk a little bit about some of the projects that we have completed already, and kind of why they needed a microgrid and what were the outcomes. So one would be the Brookville Bus Depot in Montgomery County, Maryland. So in response to many weather events and outages, Montgomery County invested in multiple microgrids across their county. So they combined this with bus fleet charging infrastructure. And some of the outcomes of that is that they reduced their lifetime emissions by 62%. They saved 100 thousands of tons of greenhouse gas emissions and increased their reliability. So they're able to handle their peak demands as well. Then there's also in San Diego, the Marine Corps Air Station. So the microgrid there was kind of incorporated to provide resiliency, incorporate renewable energy, and allow operations at this mission critical facility to continue if the grid was ever compromised or damaged. And it's also been useful a few times to help the utility while it was struggling to meet peak loads. So kind of the main outcomes we see is that strengthening resiliency, it's benefiting the community, and it's lowering emissions as well. And then there's the Port of Long Beach. And I was actually able to visit this site a few months ago, which was awesome. And basically the reason that they kind of invested in this microgrid was that their electric load was expected to quadruple. And they also wanted to increase the resiliency aspect. Say there's a grid outage, that would result in millions of dollars lost in like perished cargo. And this site is huge. They're importing a lot of cargo. There's a lot that goes on here. So we work with the port officials to design and build a new microgrid with solar, battery, and a mobile battery as well, which was really, really cool to see. But the result of all of that is greater reliability, business continuity for them, increased safety, and environmental benefits as well. And they're an example of one of our customers that had set a goal to reach zero emissions by 2030. So this is one of the ways that they're going to achieve that goal. And with that, I want to leave some time to kind of hand things off to Amanda. And I haven't touched on this too much yet, but regulations and policies and tax credits are really accelerating why people are adopting this technology as well. And yeah, I'd like to kind of hand that off to my colleague who specializes in government relations and be able to speak to this.
All right, thank you so much, Lamisa. Hi everyone, my name is Amanda Corrado. I am a federal advisor on the government relations team, and I'll be talking about federal funding for microgrids. So let me just share my screen here. Okay. Everyone can see that.
Yes, looks great. Thank you.
Okay, wonderful. So I wanted to start off with just a high-level overview of the key pieces of legislation that have been enacted over the past few years, and they mark truly historic levels of federal investment. So starting with the Infrastructure Investment and Jobs Act, it goes by a bunch of different names: Infrastructure Bill, IJA, Bipartisan Infrastructure Law. This was passed in November of 2021 and authorizes a total of $1.2 trillion in spending. Of that total, 550 billion is going to new areas of investments and programs outside of what you think of when you think of kind of traditional infrastructure, so roads, bridges, highway projects. And it's going to fund more innovative efforts like greater digitization, grid modernization, and cybersecurity. And then about a year later, in August 2022, the CHIPS and Science Act passed, and that totals close to $200 billion in funding, with around 50 billion going towards semiconductor manufacturing in the United States, as well as research and development. And then that same month, the Inflation Reduction Act passed, and this law is $369 billion of spending. And so it represents the single largest federal investment in climate and energy. Okay, and now before diving deeper into what is contained in those specific bills, I wanted to just flash this map that shows the landscape of microgrid deployments across the United States today. So this is courtesy of the Department of Energy's Microgrid Installations Database, which contains a comprehensive listing of operational microgrids throughout the country, and it's updated on a semi-annual basis. So this was updated this past October in 2023 and shows that we have over 700 operational microgrids deployed today. And I'm calling this out because in 2022, the DOE published a series of white papers outlining the strategies that it is implementing to ensure that microgrids are essential building blocks of a future electric grid. So these white papers look at the gaps and opportunities for microgrids with a 10-year timeframe, and just really speaks to the unprecedented level of attention that microgrids have begun to receive by the federal government within the past few years. And we're seeing that actively play out by the way of new and expanded funding opportunities that have been created to accelerate deployment and to support that vision. So diving deeper into the infrastructure bill, I'm sure that many of you may be familiar with this piece of legislation now that we're about 2.5 years in. But just as a refresher, it includes just under 400 different programs. And of that total, 125 programs are brand new. So in some instances, you have new offices that were created by the infrastructure bill administering new programs. And so that kind of gives you an idea of just how massive a bill of this size is and what some of those implementation challenges may be when it comes to the DOE's operation of how these programs get stood up. But in this program, or in this chart, you'll see a breakdown of that $550 billion in new spending. And again, outside of those traditional infrastructure segments, some of the biggest winners here are power and grid, broadband, and water and wastewater. And a couple of highlights that I want to note on the side here. So local governments are directly eligible for just under $300 billion in funding, but they can receive more from pass-through funds that come through their state governments. And of the funds that are directly available to local governments, about 70% are going to be competitive opportunities that they can apply directly for themselves. And then in contrast, we see that state governments are eligible for nearly $700 billion in funding. And most of the funds that states are going to receive will be via formula program, in which the amounts that they will receive are predetermined by a federal formula. And so it's really easy to track on those funds because you can look up the state, look up the program, and know how much they're eligible to receive as long as they put in their annual applications. And so DOE is going to be the primary agency administering these programs for microgrid deployment. And I do want to call out that microgrids were mentioned 5 times in the infrastructure bill. which we consider to be a strong signal reinforcing again that DOE vision that by 2035, microgrids are going to be this core building block where the DOE expects 30 to 50% of electricity generation to come from distributed resources. So microgrids will play a big piece in how that actually works for our grid. And so here I've pulled out some of the relevant infrastructure bill programs and sections from the legislation. So the left panel shows the programs in which microgrids were explicitly mentioned, starting with the Grid Resilience and Innovation Partnerships Program, or GRIP program. It's a bundle of 3 programs technically, which are called out below there. And this is one of the most significant power and grid pots of funding from the infrastructure bill. At this point in implementation, we are already in the second round of 3 total rounds for GRIP funding. So concept papers recently received encouragements or discouragement letters from the Department of Energy, and full applications are due in April or May, depending on topic area. From the first round of awardees, those were announced at the end of last year, and microgrids emerged as a very clear technology theme, with 11 projects receiving direct funding for microgrid development. Combined, those projects total about $660 million in federal investment and about $1.4 billion in total investment. But basically, the impact of the program's funding will go even further for microgrids beyond just the projects that were directly for microgrid deployment, as other GRIP-funded projects are going to be boosting renewable capacity and making investments in technologies that will support further microgrid construction over time. So the GRIP program is a really exciting opportunity that we're already seeing pay off big time for microgrids, and we expect more of these projects to come out within the second and third funding rounds. And then on the right-hand side here, these are programs that are going to be noteworthy for microgrids, even though they're not specifically mentioned as an eligible technology. We have seen these programs fund microgrids. So one example of this is the State Energy Program, which received an additional $500 million in funding from the infrastructure bill. But this program is one of these big annual programs that always receives funding from the government, and it has existed since the 70s, but the contours of it evolved over time. With the infrastructure bill, they rolled out some new program guidance requiring states to update different plans that they have to submit each year to access this funding. But it also broadened the horizons on the kinds of investments that can be made with money from this program. So with formula programs like the State Energy Program, the emphasis is really on empowering states to decide what the priorities within their states are and what projects they want to fund. And so a great example is in Maryland. We've seen the Maryland Energy Administration, which is the state's state energy office, direct a portion of state energy program funding to develop a microgrid, a campus microgrid at Frostburg State University. And that's just one example of microgrids that have been funded from that program. And then similarly with the Clean Water and Drinking Water State Revolving Funds, this is another big annual program that receives funding from the government each year. And traditionally, it has not funded a project like a microgrid, but in recent years, we've seen more and more states including microgrid projects in their intended use plans for what they will spend that funding on. And so New Jersey and Pennsylvania in specific have been kind of leaders on that. And so we're really excited to see microgrids coming up more and more as projects that are within what states are prioritizing. And those state revolving funds received an extra $22 billion in funding from the infrastructure bill. So that's the single largest investment to the state revolving funds since their inception. Okay. And now switching gears a little bit from the infrastructure bill to the Inflation Reduction Act. This is the investment tax credits, and this has been one of the main driving forces behind the country's renewable energy adoption over the past decade. But the IRA extended and expanded this credit. So it's extended through 2032, and it's expanded to include technologies like energy storage and microgrid controllers. Now, updated guidance came from the IRS and Treasury actually at the start of this month, but we do anticipate some further guidance coming out later this year. So as with any tax credit, the full impact of its implementation will hinge upon the IRS's interpretation and final regulations. So we definitely recommend that you're actively kind of watching that guidance as it comes out. But this is a 6% base tax credit for the technologies used within microgrids, like I said, including solar, energy storage, microgrid controllers. And it was expanded to include those technologies and projects that begin construction before 2025, at which point the tax credit becomes technology neutral. Now, this base credit can be bumped up to 30% credit based on meeting prevailing wage and apprenticeship requirements. And from there, it can be bumped up to 50% if the project meets certain domestic content and energy community placement requirements. And while the investment tax credit is the only credit that specifically mentions microgrids, the IRA is driving microgrid deployment in other ways as well. So here's a high-level overview of the production tax credit, and this incentivizes renewable deployment. There's also an EV tax credit. So we'll continue to see more distributed energy resources, more electrification, and more demand, all kind of setting the stage for greater microgrid deployment broadly. And I wanted to just include kind of a customer example to bring the Inflation Reduction Act to life a little bit more. So say you have a customer who wants to install a microgrid and make energy efficiency and electrification upgrades at a commercial building. Her access to credits will depend, again, on a number of different criteria, including where the building is located, her tax liability, and then again, her ability to meet, or the project's ability to meet certain prevailing wage and apprenticeship requirements. But we would want to present her with the full suite of options, including the installation of a microgrid utilizing solar, an EV charging station, and then electrical distribution and energy efficiency upgrades to complete her system. So all of this taken together, we've compiled what her potential savings could be enabled by the IRA. And so this really just demonstrates that commercial customers have been empowered to make a variety of investments that can result in significant savings for the spend that they're looking to make. And then another important piece of the tax credits available to Mary is her ability to transfer them. So I'll just flash an example that actually shows how Schneider Electric has been embracing the IRA's tax credit transferability provision. This example is in partnership with ENGIE, but this provision allows certain entities to transfer all or a portion of their credit to a third-party buyer. And there are a number of different tax credits from the Inflation Reduction Act that have transferability as an option for them. So in our scenario here, we leveraged over $70 million in tax credits that will mobilize several clean energy projects in Texas. And this agreement actually was mentioned by the Biden administration as being exactly what they had in mind for how this provision would be used and why it was included in the Inflation Reduction Act. So we plan to help others across the country take advantage of this mechanism and increase investment in clean energy projects. And so now I know that it is always very exciting to hear about all the different federal programs and incentives that are going to be big demand drivers and also serve as pathways for reducing financing gaps for customers. But I do want to also quickly touch on some of the potential challenges to be aware of when thinking about leveraging these federal funding streams. So when it comes to grant programs, I will say that the application process is lengthy. It can definitely be resource intensive as well. So if there's interest in a program, it's really important to start having discussions with partners and with potential customers around what that project proposal would entail, who would be in the partnership, and make sure that the planning for how you're going to go after that program starts as soon as possible, so that once the solicitation actually goes out, you know, you already have those pieces underway, because there are really tight turnaround times between when an application period opens and then when concept papers or full applications are due. So yeah, the timing on that is quick, and it's important to be having those discussions early. I'll also say that agency capacity, both at the federal and state levels, is limited. There's obviously more federal funding moving both from the government and then into states and local governments than there really ever has been. So there's a lot to manage, and it's important to really be monitoring closely on what's coming out from the agencies, because they might establish a timeline for a program that you're interested in, but due to capacity issues, that timeline can change multiple times. We've seen that across across a variety of programs. So it's important to closely monitor if there is a program that you're interested in leveraging, what the application window looks like, knowing that it may change, and that you don't want to miss when that happens. And then with tax credits and incentives, broadly, they can just be difficult to navigate. It gets very weedy very quickly. So there's lots of stipulations around credit plus ups or domestic content requirements. And there can be a lot of complexity to taking full advantage of those credits. So it's important to be consulting tax attorneys throughout the duration of project planning and making sure that you know what those requirements would be for a specific project. And with that, I will turn it back to Ashley or Lisa.
Thanks, Amanda. We can open it up for any questions now. You can feel free to drop them in the chat or even come off mute, and we can kind of take a go at the questions.
This is Ashley. I'm not sure if anybody else has any other questions. A couple things came in, and we were direct messaging back and forth with many of the participants. So thank you for that within the chat. That was kind of fun. But if you do have overall and overarching questions, it would be nice to kind of share those with the group. So you are welcome to come off mute if you'd like and ask your own question, or you are welcome to put it in the chat too.
Hi, Lisa. I have a question for you. So I liked how you were talking a lot about future-proofing when it comes to microgrids. Can you talk a little bit about how the process goes into future-proofing for older buildings or communities, and how maybe the early stages of planning or consulting kind of differs for them, for customers who have older buildings or maybe within older communities?
Mm-hmm. Yeah. So that's a great question. It kind of goes into a little bit. You're asking about the design process of it, or like the beginning steps. And I guess when we're designing these microgrids, that does come up. It's like a brownfield site that's existing, that has an existing infrastructure already, or a greenfield. So that would be something that's totally new and being built. So in that example, we have a lot more flexibility in how we kind of design the microgrid and what we can do. But with an existing older building, we're going to have to work a little bit more with that existing infrastructure and see how we can fit all of the components in. And this can get pretty technical with the gear and the design part of it. So it is a slightly different process, but you can find success with both paths.
Thank you.
Thanks for your question.
I think everybody's just hungry and ready to go to lunch. If there are no more questions, I'm okay taking go ahead and cutting it at this moment. We're letting you go a little bit early, which is exciting. Lamisa, I really appreciate you taking the time to put all of this together in a cohesive format, so that way we can all see all of the benefits of establishing a microgrid for your infrastructure and sustainability. So with that, I'd like to thank everybody for taking time out of your day. Again, we will be sending out the follow-up email, including the video, the presentation, and all of the collateral that you'll need to maybe pass this on to your team members and really discuss it. Also, we are open to having conversations offline. I think that's where some of this really kind of gets ironed out, and we figure out how it fits our own facilities and our own needs. So we We'll let you know as we have more of these webinar opportunities available. It's imperative that you follow us on LinkedIn, X, and Facebook so that you can keep abreast of all these things. Also, make sure you opt into our emails so we can keep you informed of new initiatives within our industry. So thank you again, everybody. I hope you all have a great day.
Thank you for joining.
Thank you.
Thank you.